Hey everyone, and welcome back to the R Programming for Beginners series. Now, in the last episode, we talked about loops inside of R, and today we take another step towards our learning journey by learning about functions in R. This episode is going to be a complete discussion on functions. So, first we are going to learn the theory about functions and then move on towards the practical coding demo. So, before we write any serious programs, let's understand functions. So, what is a function? A function is a reusable block of code that performs a specific task. Instead of writing the same code again and again, we write it once and we call it whenever we want by passing inputs into it, and then we get the output. So that is what a function is. So why do we even need to use functions? Functions are extremely useful, and not just inside of R but any other programming language as well. Functions help us to write clean code, reuse code, and also organize the code that we write. They make programs easier to read, easier to debug, and easier to maintain as well. So, now that we know about why we use functions, let's get to know the basic structure of a function inside of R. Now, inside of R, functions are created using the function keyword. So, in order to create a function, you have to first write the function name and then assign it a function body with the help of the arrow operator. After using the arrow operator, you use the function keyword to let R know that this variable right here is going to be a function. And after you use the function keyword, you have to write what you want to pass inside of the function. That is our input values, which are called parameters. And then you open a pair of curly braces and write the function body, which is the code that will run when the function is called. So that is how you define a function inside of R. Now let's talk about the function arguments. That is the values that you pass when calling a function. So as I just stated, arguments are the values that we pass into a function when we call them. So arguments allow us to work with different data. Now don't get confused. When we define a function, the inputs that we write inside of the function brackets are called parameters, as we just discussed. But when we call or use the function, the actual values that we pass into it are called arguments. So in this case, our sum is a function and a and b are arguments, since we pass these values inside of the function when we call it. So, in simple words, parameters and arguments refer to the same inputs but at different stages. Parameters are the placeholders used while defining a function, whereas arguments like these, are the real values that we pass into a function when we call it. So, we are passing the inputs of 5 and 3, and our sum function will give us an output of 8 because it is a sum of a and b, which in this case have a value of 5 and 3. So once again, arguments are the real values that will be passed into a function when calling it. Here we call the sum function and pass in our arguments, which are a and b, and they allow the function to work with different data each time that it is called. As you might also see here, a function usually returns a result. Here we call the sum function and it returned us a result of the sum of the arguments a and b. So in R, a function returns values. We can explicitly return a value using the return statement. So a function will return a value, or let's say a result, when we use this return statement. But there's also a shortcut that we will see soon. So for now, the thing that you need to keep in mind is that a function takes input, it processes the input, and it returns the value with the return statement. Okay. Now that we have some basic knowledge about functions, let's take a look at them practically inside of the R compiler. Okay, now that we are inside of the R compiler, let's define our first function. Now for a function, first we have to define a function name. So let's say our function will be called add and then numbers. So add numbers will be our function, and the name itself is quite explanatory. It will be a function to add numbers. So in order to declare this variable as a function, first we will use an arrow operator and then use the function keyword to take in the parameters. So the parameters are the values that a function will take inside of it to process and give us an output. So let's say it will take two numbers, a and b. And these numbers will be returned as their sum. So a plus b. So this is how you define a function. We created a function called add numbers, which takes two arguments a and b and returns their sum, even without the return statement. So we did define a function, and we defined what it takes as inputs and what it gives as output. But we have to actually call the function in order to use it. So in order to call a function, we just write the function's names, so add numbers, and then we pass in the necessary values that have been defined. So in our case, we have to pass in two numbers that we want to obtain the sum of. So inside this, let's send 5 and then 3. Now after this, we will run our program to see that 8 is being returned. So since we are passing 5 and 3, it will return 5 plus 3, which is 8. So that is how functions work. In this case, these are the parameters, because while defining the function, we have passed in the values of a and b. So these are the parameters, and these are the arguments, which are the values that we pass inside a function when we call it. So this is calling a function, and this is defining a function. Now let's do the same thing with a return statement. So first we will create another function. Let's say a function to multiply numbers. And then after that we will define the function. So multiply underscore numbers, and then assign it a function keyword which takes in two inputs, let's say x and y, and it will return the product of those. So we'll use the return statement and then use x times y. So this will return x times y. So let's try to call our function right over here. So multiply numbers. Let's say we want to multiply two numbers, 3 and 4. So we will first of all run this program. We should first get 8 and then 12, because 3 times 4 is 12. Now the one thing with using return and not using return is that when you don't use return, only the last statement inside of our code block is returned. So let's say we had here a minus b, right? So when we do 5 and 3, only the last statement will be returned. So this will be returned. So when we run this, you can see that we are given a value of 2, which is the value of a minus b. So if we want to explicitly return some specific value, we want to use the return keyword. And the thing about return is, after a return is used, none of the code that is below this return function is executed. So let's say we want to print I am being printed, right? And so this will, since we have used the return statement above this line, this will in fact not be executed. So if we do run, we can see that only a plus b is returned and the print statement is not executed. Whereas if we don't do return, so let's say we just do a plus b, right? So a plus b, we run this, you will see that I am being printed is being executed because this is not below a return statement. So the thing you have to note is that if you don't want to use return, you're completely fine by just giving out the last line of your code block. So a plus b, this will actually be a return value since it is the last expression that is inside of our code block of our function. So still a plus b, that is the value of 8, is being returned. But if you want to explicitly return something and not execute anything below our required line, you have to use the return statement. Using the return statement allows us to exit a function early, which can be conditional as well. Okay, now that we know about the basics of a function, let's get to learn some extra topics as well, shall we? Now the thing that we are going to talk about are default parameters. That is, when you don't pass in arguments when you call a function, you can make it so that the function uses a default value instead of the value that you input. So if we have a bit of code, you can see that here we have defined a function called power, which has x as a parameter and y equals 2 as a default parameter. Now what does that mean? That is, This means that you can just pass the value of x, you can also pass the value of y, but if you don't pass in the value of the second parameter, that is, you only pass one value, it will use y's value as 2 as the default value. So when you just pass in 4, it will take on the value of x, and it will be 4 to the power of 2 since y's default value is 2, and it will return to 16. So we'll test this out as well, but before we test that out, we want you to know about scope as well. So what is scope? The scope of a variable defines the part of code where the variable can be accessed or modified. So there is the global environment and there is the function execution environment inside of R. The variables that are inside of the functions are not accessible outside, that is, they are not accessible in the global environment, and we'll be looking at that through a bit of code. First we'll look at default parameters, and then we'll be taking a step toward understanding scope of variables. So we are back again at our compiler. First we will be talking about default parameters. So default parameters. So let's define a function which is called power, and then we'll give an arrow symbol to assign it a function value using the function keyword, and then we will use the parameters to be base and exponent, but our exponent's default value will be 2. So it will return base to the power of our exponent, so exponent. And once again, because this is the last evaluated expression of our function, it will be returned automatically without the need for using a return statement. So now that we have defined the function with a default parameter, that is exponent equals to 2, let's try and call the function. Let's first try to use it normally. So we'll call the power function. Let's say we want to do 3 to the power of 3 itself. So in this case, we are providing arguments for both the base parameter, that is 3, and the exponent parameter, that is 3 again. So when we will run this, it will return us a value of 27 because the base's value is 3 and the exponent's value is 3 as well. So 3 to the power of 3 is 27. But what would happen if we forget, or let's say if we don't include the exponent argument intentionally? What would happen is the base parameter would have a value of 3 since we have passed an argument of 3, but the exponent's value would be 2 by default. So it will be 3 to the power of 2 and it will return us 9. So that is how default parameters work. If you mention both of the parameters when calling the function, it's all good. The function performs as intended, but if we miss a parameter, it will take on a default value. So that is how default parameter functions work. Now let's understand the scope of a variable. So we'll be moving towards a new topic called variable scope. And then inside of the variable scope, what we will do is first we will define a variable x which will have a value of 10, and then we will have a function called test scope, since we want to make this function to test our scope, and it will contain a function which will have a variable defined once again, and that variable will be 5. So let's say we will return the value of 5 once again. It should, when we call this function, it would just give us 5. So first of all, let's call our function test scope. Now notice that we have defined the value of x to be 10. Now inside of our function, we have defined the value of x to be 5. Which one would be returned? Let's see. So you can see that the value that we define inside of our function is returned inside our output. But what if we do x outside of our function? So let's say print x. What do you think will happen? Well, let's see. So we can see that inside of our function, the value of x is 5. But outside, when we try to access that value of x, it will give us 10. Since this is a variable of the global scope, that is the global environment, but this is the variable of a function scope. So let's say we want to define this variable as y, and we'll print out y, and let's say outside the function we will try to access the value of y. Let's see what will happen. So when we run this, you can see that it gives us an error. First, it will output the value of y. Since we have been using this inside of the function, we have defined y inside of the function and used y inside of the function. So at first, it will give us a return value, but when we try to access this variable outside of the function, that is outside in the global environment, it will give us an error. It will tell us that object y is not found. Since we have defined this inside of a function, it is not accessible outside of the function. So I hope that is clear for you guys. And now that we are done learning about functions inside of R, let's move to a quick recap slide. So let's have a recap of today's topics. Today we learned that functions inside of R are defined using the function keyword. And next we learned about arguments, which are input values that are passed into the function for processing. We learned about default parameters or default arguments, which are preset values used when the user doesn't provide input. We learned about the return statement, which explicitly sends back a result, and we learned that it is optional as well, since the last evaluated expression inside of a function gets returned automatically, and which is this automatic return, the thing that I just said. Next up, we also learned about the scope of a variable, that is where the variable can be accessed or modified. Variables inside of a function stay local. They can't be accessed outside of a function, which is the global environment. We also learned about reusability, which is if we write a function once, we can reuse it multiple times to avoid repetition. And finally, we learned that functions help us to write cleaner code, which makes programs easier to debug, maintain, and scale. And that was it for this video. Thank you for watching. On the next episode, that is episode 13, we'll be talking about working with R packages, so don't forget to tune in for that. If you liked this video or found this video helpful, make sure you drop a like and subscribe to our channel for more such videos. And until the next episode, bye bye and happy coding. Hey everyone, welcome back to another episode of the R Programming for Beginners series. Now in the previous episode, we learned about functions, how R uses functions to perform tasks and make our work easier. And in this episode, we're taking the next step and learning about R packages. R packages are what allow R to grow beyond its basic features and become a powerful tool for data analysis, statistics, and data science. And don't worry, we won't be using real data sets just yet. Right now, the goal is to understand what packages are, why they exist, and how they fit into the R ecosystem. Once you understand this concept, working with packages later will feel much more intuitive. So first of all, let's start by answering a simple question. What are packages inside of R? R is powerful even on its own, but its real strength comes from packages. A package is a collection of ready-made functions, datasets, and help files that are designed to solve specific types of problems. Instead of writing everything from scratch, packages let us use tools that have already been carefully built and tested by experts and the R community. And some packages are stats, ggplot2, dplyr, and tidier. And you can think of R as a basic toolbox and packages as specialized toolkits that we add when we need them. So base R plus packages equals superpowers for data science. That is, when we add packages inside of already base R, we get incredibly useful tools for data science. Now that we know what packages are inside of R, let's talk about why we need them. So why do we need packages? Well, packages save us from reinventing the wheel. Many common tasks such as performing statistical analysis, building machine learning models, visualizing data, etc. have been already solved. Instead of spending time writing complex code, we install packages created by researchers, statisticians, and data scientists from around the world. This helps us increase productivity and automate our workflows. This is one of the biggest reasons why R is so popular inside data science and research. And now that we know why we need packages inside of R, let's talk about base R, that is basic R without any packages, versus external packages. Some functions come built directly into R. This is called base R. And it includes essential tools like basic math, simple plots, and summary statistics. So mean, sum, and the basic plot function in order to see plots. This is basic R. However, many advanced features do not come pre-installed. These features are provided through external packages, which we install only when we need them. And now this design keeps R lightweight and flexible. Some of the functions that are associated with packages are ggplot, filter, and mutate. We install packages only when we need them, and this design keeps R lightweight and flexible. So when you add packages to base R, it gives you more power for data science. Now let's talk about installing packages. So before we can actually use a package, we must install it. And installing a package means downloading it from CRAN, the Comprehensive R Archive Network, and storing it on your computer. So in order to actually install a package, we will have to open our R environment and run the install.packages command, and it installs the packages on your computer. The actual command is install.packages, and inside of the parentheses, the name of the package that you want to install inside of quotes, and it will install the package on your PC or on your device. And this step is usually only done once unless you remove R or want to update the package later. So it is a one-time process. Now only installing a package isn't enough to use it. Each time you start a new R session, you must tell R which packages you want to use. So therefore we have to load packages inside of R. So after we install an R package, we tell R what package we want to use by actually loading the package into our memory. And once loaded, all of the package's functions become available for that session. So we can use the package successfully. So to load a package in R, we use the library function. So it's library, and inside the parentheses, the name of the package that you want to use. So if we wanted to use a package called ggplot2 that we just installed inside of our R session, we would have to type out the library function, and then inside of the parentheses of the library function, we would have to write the package name. So ggplot2 inside of this parentheses. And like I said, once loaded, all of the package's functions become available for that R session. Now, you know how to install packages and you know how to load and use packages as well. But what about searching for the right packages? R has thousands of packages and new ones are added all the time. Knowing how to search for packages is an important skill. We can search for R packages and functions directly inside R, or explore them online using the CRAN website. As you gain experience by installing packages, you will learn what packages are commonly used for different tasks. So you will install packages, use them and gain experience, and then eventually you will naturally learn which packages are commonly used for different tasks. So inside of R, help.search or question mark keyword are used to search through all documentation and install packages to find the functions related to a specific keyword that you want to search. And now that you know about searching packages, let's talk about updating packages inside of R. Packages are updated regularly to improve performance and add new features. Keeping packages up to date helps us to avoid errors and ensures compatibility with newer versions of R. So, updating packages is a simple maintenance task that becomes a part of good R practice. And inside of R, you update packages by using the update.packages command. And that was it for this video. We learned that packages are what turn R into a complete data science ecosystem. And while we only learned the theoretical knowledge behind packages inside of R, we will for sure make use of this information in further videos. In this beginner series, our goal is to understand what packages are and why they matter. And like I said, in future R courses, we'll actively work with popular packages to analyze data, create visualizations, and build models as well. For now, we have to focus on the concepts. Once you understand packages, using them will feel natural and intuitive. And that was it for this video. In the next episode, we're going to be discussing about basic input and output inside of R. So we hope you stay tuned for episode 14. And until then, bye bye and happy coding.